Today we are learning about the parts of similar triangles. So if two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. So this first one here is going to be altitudes. So I have triangle A, B, C, and BD is going to be my altitude here. And then I have triangle EFG, and FH is going to be my altitude here. So my altitudes are going to be proportional to the corresponding side, so I can write BD, altitude of my first one here, over FH, altitude of my second triangle, is going to be equal to AB, this side here, over EF, the corresponding side over here. The second one is going to be angle bisectors. So I have QS is my angle bisector, and it's cutting this into two congruent angles. And I have UW, which is an angle bisector, cutting angle U into two congruent angles. So I can have my angle bisector QS, set up this proportion, over angle bisector in my second triangle, UW, equals, I'm going to take the side of my first triangle, QP, over the same corresponding side, UT, in my second triangle, UT. And then lastly, it's going to be medians. And that is going to be a line that cuts the base into two congruent pieces. So we have HJ as our medium, so GJ and JI are now two congruent segments. And then we have LN as our medium, cutting KN and NM into two congruent segments. So we can say HJ, our first median, over LN, second median, equals this side here, GH, over that same corresponding side, which is going to be KL. So for example 1, I'm given the similar triangles. So STU, triangle STU, is similar to triangle DEC. And I want to solve for X. So I'm going to set up a proportion. And I have SW, which is cutting TU into two congruent pieces, and DF, which is cutting CE into two congruent pieces. So that's going to be the medians. And so I'm going to set up a proportion using those. So I'm going to take the median, SW, from my first triangle, X, over the median for my second triangle, DF, which is 15. Setting that equal to, and I'm going to take side TS, which is 16. And I need to take the same side in my second triangle. So ST is going to correspond to, those are the first two letters, DE in my second triangle, DE, first two letters, so 20. Then I'm going to take and cross multiply to solve this. So I'm going to have 20 times X, so 20X equals 15 times 16, which gives me 240. Then I'm going to divide by 20 on both sides. I'm going to be left with X equals 12. Going on to number 2, I am given the similar triangle. GHI is similar to triangle MLK, and I need to solve for X. So I have HJ here forming a right triangle on the base. That's going to be an altitude. Same thing here. I have LN as my altitude, forming that right angle on the base. So I'm going to set up a proportion, first starting with my altitude. So I'm going to take the altitude JH, which is 10, put it on top of the altitude of my second triangle, LN, which is 8. Then setting that equal to, I'm going to take this side here, which is IH, which is X. And then I need to take the same corresponding side over here. So IH or HI are the second two letters in my statement. So I need the second two letters in my second triangle, LK, which is going to be 14. Then I'm going to take and cross multiply. 10 times 14 is 140. 8 times x is 8x. Divide both sides by 8. I am left with x equals 17.5. Moving on to the second page, we have the triangle angle bisector theorem, which says an angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. So we have our angle bisector, BD, and it separates the opposite side is AC, into two segments, AD and DC, that are proportional to the lengths of the other two sides, AB and BC. So when we set that up, I'm going to have the first segment that it's divided into, AD, over that second segment it's divided into, DC, equals the ratio of the other two sides, so AB, over opposite side, BC. Looking at example 1, so I have KM represents an angle bisector. So that means KM is cutting angle K into two congruent angles. And then we need to solve for X. So we're going to set up a proportion up here with the two segments that my angle bisector creates. So the first segment it creates is JM, so I'm going to take that one, 4.8, and put it over the second segment it creates, which is going to be ML, or X, and set that equal to a ratio created by the opposite side, so JK, which is 12, and then KL, which is 18. Then going to take and cross multiply. So I've got 4.8 times 18, which is going to give me 86.4. Setting that equal to 12 times x, or 12x. Going to divide both sides by 12. Those cancel. I'm left with x equals 7.2. Looking at number 7, I again have KM is my angle bisector, so cutting K into two congruent angles, and then we can set up a proportion with the two segments it creates on the base here. So I'm going to take that first segment, which is 36, or LM, create a ratio with that other segment that it creates, MJ, or 40, setting that equal to the opposite side, and 36 is in the top here, so it's going to be the same triangle here, so I'm going to put X over here. And then my opposite side of my other triangle, which is going to be JK, which is 54. Then we're just going ahead and cross multiplying. 36 times 54 is going to give me 1,944. And then I have 40 times x, so 40x. Going to divide both sides by 40. And I am left with x equals 48.6.